All right, let's dive right in. Today we're tackling a massive concept, one that totally reframes how we think about, well, just about everything, from physics to biology to AI. We're talking about teleology.
I mean, just stop and think about that for a second. A river always finds its way to the sea. A tree grows towards the sunlight. An animal adapts to its niche. There's this undeniable sense of directedness, right? A kind of convergence. And look, this isn't some kind of mystical idea. It's a real fundamental property of how complex systems actually work.
Okay, so the word purpose can be a little tricky. I know what you're thinking. It usually makes us think of a conscious designer or some kind of grand plan. But that's not what we're talking about here. Not at all. We're exploring a purely scientific, almost mechanical kind of purpose. A directedness that just naturally emerges from the laws of math and systems theory.
So this is the modern working definition. It's got nothing to do with fate or a pre-written destiny. It's all about things like attractors, feedback loops, and constraints. It's really just the science of why things tend to settle down, find their balance, and organize themselves over time.
So it's absolutely crucial we draw a line in the sand right here. The classical idea, going all the way back to Aristotle, was that an acorn has this built-in purpose, a telos, to become an oak tree. But the new science says, nah, that's not quite it. The process is really driven by the system's dynamics, how that acorn's genetic program interacts with an environment that favors certain outcomes. One is metaphysics, the other is mechanics. And that single shift, it's a total game changer. It pulls the idea of purpose out of the clouds and puts it right here in the real world, where we can actually measure it, predict it, and even build it.
Okay, this is where it gets really cool. How do we actually visualize this mechanical purpose? Well, the most powerful tool we have is a metaphor, a landscape, full of rolling hills and deep valleys. This one idea is the key to understanding how systems can find their way without needing a map or any instructions.
Now, in science, this landscape has a fancy name. We call it a potential field or a phi field, but don't let the term fool you. It's a simple idea. Think of it as a map of stability. The high peaks and ridges are unstable, high-energy states, and the deep valleys, those are the stable, low-energy, preferred states that everything is drawn toward.
And the rule for moving on this landscape is something you already know intuitively. It's called gradient flow. It's literally just like placing a marble on a bumpy surface. What's it going to do? It's going to roll downhill, right? It'll always follow the steepest path it can find until it settles in the bottom of the nearest valley. That valley is its attractor. It's the system's natural endpoint. It's a simple, powerful, and totally universal law.
So this whole engine of rolling downhill to find a stable state can actually show up in two very different ways. A goal can either just emerge naturally, all on its own, or it can be explicitly engineered into a system from the start. Let's break those two down. First up, we have the emergent kind, evolutionary teleology. In this case, there's no pre-programmed goal. The purpose, if you can call it that, is simply survival, and it emerges from the pressures of the environment. The landscape idea still works perfectly, but with a little twist. We call it a fitness landscape. And instead of rolling downhill into a valley of low energy, natural selection is a force that pushes life to, on average, climb uphill toward the peaks of higher fitness, better adaptation, and better chances of survival.
Then you've got the other flavor, cybernetic teleology. And this is purpose by design. It's the one we're all actually familiar with. Think of the thermostat in your house or the autopilot in a plane. The system has a very explicit goal programmed right into it, like stay at 72 degrees. It is constantly measuring where it is, comparing that to where it's supposed to be, and then calculating corrections to close that gap, to minimize the error. It's a classic feedback loop designed for one thing, hitting a target.
And putting them side by side like this just makes the difference so clear, doesn't it? One has a goal that's implicit, coming from the outside world. The other has a goal that's explicit, built right in by a designer. One works through selection and random change, the other works through precise measurement and correction. But here's the kicker. They both produce incredibly powerful, goal-directed behavior.
Now, you might be thinking this is a neat idea for biology or robotics, but we're about to zoom way out. Because this concept of a potential landscape, this phi field, isn't just a niche idea. It is, and I'm not exaggerating, one of the most fundamental, unifying principles in all of science.
And the critical thing to get here is that this landscape isn't just a nice metaphor. It is the actual operational logic in so many different domains. In physics, the principle of least action says systems will find the most efficient path. That's a valley. In thermodynamics, chemical reactions proceed to minimize free energy. Another valley.
In machine learning, the entire point of training an AI is to minimize a loss function. You guessed it, find the lowest point on the landscape. We already talked about fitness landscapes in evolution and error functions in cybernetics. It's the same deep logic playing out everywhere, just with a different name. The core rule is always the same: find the bottom of the valley.
And that just brings us to the beautiful, simple heart of the whole thing. What teleology really does is strip away all the mystery from purpose and shows us what's underneath: geometry. It's all about the shape of the landscape of possibilities and the predictable paths that systems take across it. It's the mathematical structure that guides how things change, how they develop, how they become what they are.
So, I'll just leave you with this to chew on. If all this directedness we see everywhere, in the cosmos, in life, in our own technology, is really just a fundamental consequence of system dynamics, just math and geometry, then what does that imply about the goals and purposes we feel so strongly in our own lives, in our societies? Are we too just following the contours of some unbelievably complex landscape? It's a pretty profound question to think about.